Okay, here's an example of calculating delta H of reaction. We are going to calculate the standard delta H of reaction for N2 gas reacting with 2 molecules of O2 gas to produce N2O4 gas. And we're going to do this using this really straightforward equation here. We're going to write it out. Most of the time when you do this, you're not going to take the time to write this out every single time. But for the first couple times, it's good to do it, just to make sure that you're putting everything in the right spot. So we're going to do products minus reactants. We have one product molecule, and its coefficient is 1. So it's going to be 1 times the enthalpy of formation of N2O4 gas. Remember, you got to make sure that you keep track whether it's a gas or a liquid or a solid or whatever. And that's all of your products. And from that, we're going to subtract the total enthalpy of formation for our reactants. We have an N2 molecule. Its coefficient is 1. So 1 times the delta H of formation of N2 gas. Plus, we have an O2 molecule. Its coefficient is 2. 2 times the enthalpy of formation of O2 gas. Now that we have this problem all set up, what you're going to do is go to Appendix 3 and look these values up. So you're going to do 1 times the value of the delta H of formation for N2O4 gas, and if you look that up in the right spot, you're going to see that it's 9.66 kilojoules per mole. And then from that, we're going to do 1 times the enthalpy of formation of N2 gas. You can look it up. You're going to see it's 0, but I do want you to know, this is something I expect you to know for your test, that N2, that's how nitrogen exists in its natural state, and that enthalpy of formation is 0. And then to that we have 2 times the enthalpy of formation of O2. That's the natural state of oxygen, so the enthalpy of formation of O2 is also going to be 0. And the delta H of this reaction then is 9.66 kilojoules per mole. Okay, so that's pretty easy to do. The calculations are not that tricky. Let's look at another type of example. If I tell you that for the reaction H2 gas plus 1/2 O2 gas produces H2O liquid, the delta H for this reaction standard is negative 285.8 kilojoules per mole. With that information, what is the delta H of reaction for 2 H2 gas plus O2 gas to produce 2 H2O liquid? You could, to solve this problem, there's actually 3 different ways you could do it. You could just look it up. You could use this equation, you could write one out, you could look the values up in your appendix, you could plug them in and you could get a number from that. And that would be easy, but that's going to be the most tedious way to do it. You could look at compare the 2 reactions side by side, and you could say, well, I see that they are the same reactants making the same product. The only thing that's different is the quantity. This reaction has twice as much of everything as the first reaction. And knowing what you know about working with thermochemical equations, and I told you last week, 3 rules for working with thermochemical equation. Rule number 1, rule number 2, rule number 3. Reactions multiply, or delta H multiplies as a reaction multiplies, as the quantity changes. So when we double the amount that we're reacting and double the amount that we're producing, we're also going to double the delta H. That's really the easiest way to go about solving the problem. Just understanding that basic principle of thermochemical equations. And there is a third way to do it, which is actually even trickier, and I'm kind of hesitant to even talk about it. But what you could do is derive. You could use this equation to derive the value of delta H formation for water, and pretending like you couldn't look it up in the book or something. You could say, well, I know that this is going to be 0. That's the natural state of hydrogen. I know this one's going to be 0. That's the natural state of oxygen. And so you could say that must mean, just like in this example that we did up here, the delta H of formation for water is going to be negative 285.8 kilojoules per mole. I've got 2, and go from there. That would actually be the hardest way to do it. We're going to use this principle to talk about something called Hess's law, and I'm just going to go ahead and pause it, even though we're still in the same section, start a new video for Hess's law.